Welcome everyone. Over the past 4+ years, Hudi Presto integration has evolved a lot, and in this talk, we are gonna take you through that journey and some cool, exciting features that are coming up in the new Hudi connector. Before that, I'm Sagar Sumit, a database engineer at Onehouse. I'm also a committer at Apache Hudi. I mostly work on the transactional engine of Hudi. And prior to that, I was with AWS Aurora, working on their relational data service for the cloud. I also worked at CrabPay, building their financial data infra. And I started my career with CDC Golden Gate at Oracle, doing heterogeneous database replication stuff. Over to you, Sida, to take it forward from here.
Thanks, Sagar. Hey, welcome everyone. My name is Bhavani Sudha. I'm a PMC member of the Apache Hudi project. I used to work at Moveworks as a software engineer, driving the data lake efforts at Moveworks using Apache Hudi. Prior to that, I used to be part of the Presto team at Uber, where I got to contribute to the early integrations of Hudi and Presto. In my initial years at Uber, I was also part of the real-time data ingestion platform team at Marketplace at Uber. And prior to that, I used to work at the Voldemort team, where I got to experience, cool challenges of a distributed NoSQL store. So mostly, I've been doing data ingestion and data platform all through my career so far. Okay, cool. Thanks for the introductions, Ali, as well. Let's get to the session. Here is our agenda. We'll briefly introduce Hudi, what is the motivation behind, and we'll discuss how the Presto-Hudi integration has evolved over time. Then Sagar will walk us through the more recent development, which is the Presto-Hudi connector and what's happening in that space. He's also going to discuss a lot of optimizations that this connector leverages. And he'll give us updates on what's the roadmap ahead and the community. And finally, we'll open up for questions. Okay. So it's important to understand how Hudi originated. Hudi was born in 2016 in Uber when it was in hypergrowth mode, where Uber was trying to transition from like warehouses to lakes. The nature of the problems that we were solving were not just complex; they had to be solved at scale and demanded database design guarantees, such as asset guarantees, transactionalities, etc., on top of immutable stores like HDFS cloud storage. So at that time, roughly we had to ingest like 120 terabytes of data every 8 hours or so, like a bulk load every time. And the actual change itself was in the order of 500 GB or something like that. This would change data from our OLTP workload to Parquet format, like as raw tables, and then there'd be like large jobs or ETL pipelines running on top of these raw table. Those do full recompute as well every few hours. So as you can see, this is like wasteful in terms of resources like IO, compute, network, etc., and extremely poor end-to-end ingest performance. And we had no control on concurrency, things like failure, recovery, etc. Like if some pipeline were to fail in between, they would have consumed a lot of resources, returned some data, partial writes. We had to clean them up, trace, trigger like retries, and also cascade all the retries all the way through the downstream pipeline. So it was such a nightmare. And these were the motivations for Hudi. And we quickly realized the missing pieces that we need to build a solution around this whole problem. We needed a way to absorb changes in records, updates, deletes, and new records. That way we don't have to do like bulk load every time. And then while we are processing these changes, we had to make sure that the queries do not see like partial data. They always had to have a consistent view of the table. So that required us to build snapshot isolation. And then we also had to revisit, like go past in time and kind of understand what happened to a table at some point in time. So point in time or like time travel queries were essential too. These just improve the ingestion performance up until the raw tables, right? Like we also had to speed up the downstream ETL pipeline. So how would we do that? We would need to hand out changes that happen to these tables, right? So incremental querying capability was also key. While these were happening, we also need like a suite of table services that always have an eye for optimizing the table and keeping like managing the table. So as you can see, these sort of design challenges are no different than any database design. So what we did was we named this like transactional data lake at that time, but it is very similar to Lakehouse today. We made sure that this entire architecture is serverless transaction layer that sits on top of lakes. There are files, and we build metadata and transaction logs that can be exposed to writers and queries via table APIs. We introduced two storage types: copy on write table and merge on read table. We'll dive into them a bit in the upcoming slides. But yeah, so these terms are also so popular that they are heavily borrowed outside the industry today. So with these database abstractions and ability to process changes incrementally, we were able to solve the problems that we described earlier. And that is a short introduction to how Hudi was born. Let's quickly dive into the table types and query types. I think that would be helpful to understand the Presto Hudi evolution and like kind of understand like what support you can expect in each of those Presto versions. So copy on write table, think of it as like a very simple table with Parquet files. What happens is like when there is an update to records that are sitting in a file, that batch of update would cause a reversion, like a complete rewrite of that file, like versioning it and then capturing just the updates. So as you can see, updates are expensive, meaning like every update that touches a file would cause that batch of updates could cause a rewrite of that file. But this is also very easy on the read side because all query engines have to do is just read the latest versions of files and then they're on their way. So, but merge on read table, on the other hand, is more flexible in the sense that it's built for optimized ingest performance, like faster ingest performance. Here, updates do not cause a full rewrite of the file. Rather, the updates are queued into log files and they are compacted periodically to produce new version of base files. So the challenge here is if in between compaction, if the queries were to hit the merge on read tables, to get the latest snapshot, they will have to do this merging process on the fly. So it takes a hit on the data, like the data is fresh, but it takes a hit on the right side, the compaction time, but the ingestion is super fast because you just queue the logs. Whereas a copy on write table is much faster and in terms of read side. So that's the table types. For the query types, there are three different query types: snapshot query, incremental query, and read optimized query. Snapshot query, as the name suggests, gives the latest snapshot of the table at a certain point in time. What this means for merge on read table is this merging of base files with the log files, which are Avro formatted. And incremental query is like already we discussed, gives the ability to query the changes that happen to a table. So you could always say, give me all the changes that happen to this table after some point in time. And read optimized queries are there for like more faster performance, and they're comparable to any non-Hudi columnar table because they expose the neatly sized Parquet files that the query engines can access. All right, and this is the overview of Hudi platform and what it has to offer. As you can see, there are like three layers: the storage layer, the database transactional layer, and then the execution of the runtime layer. And there are like different components that work together to deliver all the awesome features that Hudi has to offer. And there are more resources on these if you head over to our website or to the GitHub RFCs, and we have resources on them later in the slides. Okay, so let's move to the Hudi Presto evolution itself. So this picture that you see here gives the high-level overview of how Hudi Presto integration has evolved over time. We are going to dive into each of these sections in a bit. Okay, at the very beginning, we were trying to figure out like how do we support basic querying of Hudi tables via Presto. And this was a very first integration. Hudi was a very first data-like type of project that integrated into Presto in this way. And when exploring with the Presto community together, we came up with a very simple idea to introduce a custom annotation called use file splits from input format. What this did is it signaled Presto to use Hudi's input format dot get splits method whenever it looks into a Hudi table. So what users had to do was drop a Hudi Presto bundle in the Hive Hadoop 2 plugin, and then they can easily do snapshot queries on COW table and read optimized queries on merge on read table. So this was good. It already powered hundred thousands of queries at Uber, Presto queries at Uber, on top of hundreds of petabytes of data that was sitting in HDFS registered as Hive table. This was all nice, and we also started seeing that, okay, now we are seeing like more name node calls. What could be happening there? And so what we found out was the splits returned by the input format dot get splits was not enough for Presto because it was looking for more information such as file status and block locations. So what we did was, okay, let's change this implementation a bit to be nicer with the name node calls. So we used a path filter implementation that is Hudi specific and took a compile time dependency on Presto. This path filter implementation can actually take in files listed by Presto and then filter them for the Hudi versions, like the latest versions, and give back. So this kind of improved the name nodes. And yeah, we didn't have to do jars anymore. Like anyone who is in this version can directly start querying Hudi tables if they are registered to Hive already. So, and like this was all awesome. We wanted to expand the use case to also support snapshot querying on MOR table. So going back to my previous discussion, what this requires is the ability to read both base Parquet files and Abro Abro formatted log files. So this was not straightforward. So we had to do a design around this to support this particular use case in Presto. Presto, this is normally this is supported in Hive using input format. So Hudi has input format for doing for supporting snapshot queries on merge on read tables. This works out of box in Hive. In Presto, Presto doesn't use the record cursor directly. So what we did was we introduced a way to recreate a Hudi split from the Hive split. And this Hudi split can be passed to Hudi record readers. And how we know we need to create the record readers from Hudi's input format is signal Presto to look for this custom annotation, use record reader from input format. And if it sees that custom annotation, it would create a Hudi input format for snapshot queries on merge on read table and create a record reader and pass the Hudi splits to that. So that enabled us to do snapshot querying on merge on read tables. We just expanded this to also support bootstrap tables in Hudi in the next phase. While these were all going, we always was looking for improving the file listing performance. And this is the same intent as the path filter. But with this particular versions, what we did was we got rid of path filter. We added a new implementation for directory lister for Hudi that would use the Hudi table file system view to fetch data and cache them for the queries lifecycle. Sagar would be talking more on this. So this improved the file listing, and while the next phase, like we were in parallel looking to see, okay, we have all awesome features in Hudi, like nice new optimizations that are happening in Hudi side. How do we bring them all in Presto? This is where we were thinking about a new connector, Presto Hudi connector, that can help us bring all these optimizations independently. So I invite Sagar to talk more about this and give more information on this space.
Sure. Thanks, Sudha, for taking us through that journey. Before I talk about the optimizations, let me just start by talking about the motivations for writing a new connector. Presto Hive connector itself does a lot of things for Hudi tables. Our current integration with the Hive connector has stood the test of time. But as we pushed out more features in Hudi, which optimized both ingestion latency as well as query latency. We realized on Presto side, in order to integrate with those features, we'll have to make more and more code changes in the Hive connector core reading path, the hot path. So together in discussion with the community, it was we took a call that it's time to write a Hudi connector. Apart from adoption of new Hudi features and performance and stability that I mentioned, there's also one more point. If we look at all the modern Lakehouse storage formats, such as Delta Lake or Apache Iceberg or Hudi, they all interact with the Hive store. You go ahead and look at the usage, the Presto connector docs open for Delta and Iceberg. They will ask you for Hive Metastore URI. So they need to interact with Hive Metastore, and they heavily extend bits and pieces from the Hive connector. This begs the question, should the Presto Hive community carve out a clear interface for integrations with these storage formats, so that all the optimizations that are going on in Hive connector are also available to all these storage formats. But that's a discussion for another day. But already I see there is some work going on, and we'll see in the design how we reuse many of the stuff that is already there in Presto. So next slide, please. If you look at the design of the Hudi connector, as I mentioned before, even we use the Hive Metastore, and we make use of the extended Hive Metastore interface provided by Presto. What is different from the Presto Hive connector is that we have this table meta client, Hudi table meta client, which gives you a timeline of all the events that happened in a Hudi table. So together with that timeline and the table metadata that's synced to the Hive Metastore, we get a complete transactional view of the table. And that unlocks other capabilities. So for instance, Sudha talked about different query types, right? Snapshot, read optimized queries, and incremental queries. Without this transactional view, it's very hard to support this incremental query type. Another thing that we did, wherever possible, we are reusing the optimized readers provided by Presto itself. So for instance, for copy-on-write Hudi tables, copy-on-write Hudi tables are basically Parquet files, right? So the Hudi page source does nothing but delegates it to Parquet page source itself. But for merge on read tables, we wrote a custom log file reader, which merges the log blocks with the base files to give you a real-time snapshot view of the table. We have the links for the design, which talks in more detail. Let's dive into the new features and the optimizations that we did in Hudi. So first is metadata table. Well, if you look at the life cycle of a query, can you go to the next slide, please? The life cycle of a query, after parsing, you do planning, and then you from planning stage, you generate splits, you and throw the results, right? Each of these steps involves certain optimizations. The planning stage itself, efficient metadata fetching is very important at that stage. And in Hudi, this metadata is stored in H file. Unlike other Lakehouse storage formats, which use Parquet or Avro for storing metadata, Hudi uses H file. And we'll go into the reasons behind this choice. But what this helps us with is now we are able to eliminate recursive file listing operations, and using different indexes within the metadata table, we are able to prune not just partitions, but files, and then go one level deep to prune records as well. Uh, Before we get to that, let's just quickly talk about some traditional optimization technique in data warehouse. We know this clustering is very common technique to optimize data layout. There is always this trade-off between faster ingestion and faster querying. For ingestion, you want to write to small files as soon as possible, while on the query side, you want your data to be clustered, not too many small files to avoid file listing, and if possible, uh, my data should be laid out in such a way that for a sort key, I get the advantage of data locality. And that's where clustering is a very neat technique. It's been in databases and data warehouse to balance that trade-off. And the unique thing about clustering in Hudi is that it runs in the background. Um, so it does not block ingestion at all. You can continue updating, deleting the table. The index will get updated. Your clustering will keep running in the background. So it's a totally asynchronous process without blocking ingestion. We even benchmark clustering. Next slide, please. Hudi supports these different tunable clustering methods. You could do clustering based on linear sorting or Z ordering. So we picked GitHub archive data for 1 year, roughly 1 billion records, half terabyte of data. We benchmark with this with latest Presto Hive connector. What we found is without any clustering, it's definitely bad. But even these different clustering methods, depending on the cardinality of your predicate, the column by which you're filtering, right? It could matter which sorting or which clustering method you choose. So Hudi gives you this flexibility to tune your clustering according to your access patterns. Um, Now let's come to let me take you back to the metadata table again. Um, uh, and some upcoming features in Hudi connector. Sudha mentioned about incremental query, right? And I also talked about how transactional view of the table can unlock incremental query support. So that's a current ongoing work, querying change streams. We want to integrate incremental query in Presto Hudi connector as well. Um, Incremental queries only scan relevant files in that query window. So that proves to be very useful for any derived tables, right? You want to scan something and create a derived view out of it. Incremental change strings are great. Coming back to the metadata table, why we went with H file. Um, so H file has this very nice um, let me put it this way. When you're when I say we want efficient metadata fetching, what do I basically mean by efficient? It's nothing but doing fast point lookups and range lookups, right? I don't want to read the whole index. If it's possible to avoid that, given a query, I know that I only need data for a certain filter column, then why read the full index? So H file has this nice property, like it's a sorted key value data is laid out in a tree map kind of structure, and what it unlocks for us is that you can do this prefix based lookup and point lookups in a very efficient manner. Let's take this example, right? So suppose you get a query, select ABC from some table filtered on column 2. Now, the key composition that we do, here the value are the column stats, but the key is column name, partition name, file name. There is a reason behind this choice of key composition. It allows you to, so for column 2, you just need to scan the contiguous slice of data block pertaining to that particular column, right? So you get the advantage of data locality on top of the H file format itself. And using that, leveraging that, we were able to make this lookup uh, in order of number of predicate columns instead of order of number of table columns. Uh, and you can see from the graph this speed up. We compared lookups across different file formats, H-file, Parquet, and Avro. As you increase the number of columns, sure, it increases across all formats, but in H-file is much faster, more than 10x faster compared to other formats. So this work is also ongoing. Column stats index, it's already there in Hudi, and it gets created asynchronously as well without blocking ingestion. Uh, but the capability to read that through Presto-Hudi connector, it's an ongoing work and should be out in a future version. Next slide, please. With that, I just point you to the documentation. If you want to learn more about the early integration, this is a nice blog, Presto blog itself. And about the connector, there is documentation on how to use that connector. It should be out in the next Presto release. It's there in Presto master code. And if you are interested in the design of the connector itself, then head over to RFC44 in Hudi GitHub. So that's all about the connector. I just want to take a moment to talk about community and roadmap as well. As you can see, Hudi is being used across different enterprises operating at different scale, from few hundred terabytes to few exabytes. And over the past 2 years, we have seen phenomenal growth in adoption of Hudi. There has been 5x increase in number of monthly downloads, and users are, if you look at the GitHub issues itself, that gives it gives an idea of how rich the Hudi community has grown. And Ali started with actually mentioning that I work for a Hudi company, Onehouse Hudi company. Well, I'm humbled, but the Hudi community is so diverse. There are 20 plus PMC committers from 10 plus organizations, and we have just 3 PMC members in Onehouse. The way we operate, you can, the ongoing design discussions, you can just go ahead and look at GitHub, filter PRs by RFC. In the roadmap, for the Presto-Hudi connector, as I mentioned, column stats and incremental query support is an ongoing work. We have a couple of other indexes in the metadata table, and we want to enable full integration with that. Comprehensive schema evolution support. Then there are certain changes at the file group abstractions. And going forward, we want to support full DDL, DML for time travel updates and deletes. And we hope to complete all this by end of this year. To engage with our community, just we do a weekly community syncs as well, office hours kind of meeting. I wish more and more people, I hope more and more people will join that. That's pretty much it. Thanks for this opportunity, and we are open to questions now.
Great. Sudha and Sagar, what a fantastic presentation. I'm so excited to see all of the work and innovation that's been going into the Hudi Presto connector. I think there's a lot of exciting things to come. We are kind of at the beginning of this Hudi Presto journey. But we've been talking a lot today about the open data lakehouse. I think from your perspective, that's a real thing, a real trend. I don't know if you have any thoughts on the open data lakehouse and Presto and Hudi's role into that, but I'd love to hear more. If you have any thoughts on what that kind of means.
Yeah, sure. Well, sometimes it feels like open is being used as a misnomer, but Presto and Hudi are two great communities which live up to that open standard. And actually spearheading that change, you notice that Databricks recently open sourced a lot of features which was previously locked. For the open Lakehouse itself, I think from user standpoint, it's more than performance. It's the usability and flexibility that matters a lot. And the kind of flexibility that Hudi provides with different table types and query types, I feel in the long run that's what would be more valuable for the users to build a lakehouse. Sudha, you have any thoughts here?
I cannot agree more. I'm more excited for the features that are coming up, and yeah, want to see where things are going.
Awesome. And we already had Blinkit presenting about, their Lakehouse with both Presto and Hudi, which was exciting to see. So I think we're going to start seeing a lot more of this in the space, and it's really great stuff. Okay, question from Roy. He likes the innovation. Awesome. How are you addressing the need for higher write throughput in CDC use cases? You may see 1,000+ updates per second.
Do you want to take it, Sagar?
So is that in regards to the connector itself? Well, I'm not sure. So this is more like a question on the write throughput. We do have CDC integrations. So for example, with Debezium, there is a source. In Hudi, we have Debezium source through which you can replay CDC logs. But that's more on the right side of Hudi. I'm not sure how that interplays with Presto Hive or Presto-Hudi connector.
Yeah, I guess I think
Did
Roy
I
replied.
get
Yeah,
that right? I'd be happy to take this offline and understand more about the question.
Great. Sounds good. Okay, so I think we're a little bit over time, but what a fantastic presentation. Again, I'm so excited to see all of everything that's happened over the last few months and everything to come when it comes to the Hudi and the Presto communities working and doing a lot more together. Thank you, Sudha. Thank you, Sagar. Appreciate your presentation and your time.